So we know that life has existed on Earth for a very long time, but humans haven't. So how do we take a look back at what existed before we did? And there's one thing that we use most often, which is the fossil record. And the fossil record is really cool. So sedimentary rocks are areas where we would find a rich source of fossils. And these are kind of areas that would have maybe been like a mucky pond or a lake that over time the sediment has hardened from something that might have been kind of like mud into something hard like a rock. And as it did that, it kind of, there was an animal that died there, and its skeleton or hard parts got preserved in that muck into the rock and then made some sort of imprint, and we call that a fossil. So while the fossil record is awesome, and it's one of the only sources of information that we have, besides things like nutrient samples from the fossils themselves, it's extremely biased. So ask yourself these questions. What kind of organism is more likely to leave a fossil? Something that existed for hundreds of thousands of years, or something that only existed for a short period of time? Right? So if something was on Earth for a very long period of time, then it's more likely to have left a fossil than something that only existed for a very short period of time. So things that were more adapted to the environment at the time had a longer lifespan, or just even existed on Earth for a longer period of time, are more likely to leave a fossil. In the same kind of note, what's more likely to leave a fossil? Something that was spread all over the Earth's surface, or something that was only found in one specific small area? Well, the widespread organism. So organisms that were able to range far, were able to reproduce and produce lots of organisms, are going to be able to have more chances to leave a fossil than something that was kind of contained in one spot or didn't produce a lot. And then here's another one. What's more likely to leave a fossil? Something hard, like a skeleton, or something soft, like an amoeba? Well, something really hard, right? So hard parts. So organisms that had things like skulls and skeletons, or even shells, teeth, those are going to be much more likely to leave an imprint in a rock rather than something soft and squishy like an algae or a protist that doesn't have a hard shell. So with as many fossils as we've found, there's so many more that we will never know about because they would have never been able to leave a fossil. So when we find a fossil, how do we tell how old it was? One way is by looking at how deep down it is, right? By the strata, the further down in the earth it is, the older it is. But we can also use something called radiometric dating. And if you remember what an isotope is, it's a chemical that has a different number of neutrons. For example, carbon. So we have carbon-12, which is the normal carbon, 6 neutrons. And then we have carbon-14. So organisms throughout their life, they eat food and then they get new sources of carbon. But when an organism dies, it stops acquiring carbon. So carbon-12 is the stable normal carbon. That amount doesn't actually change. What changes over time is the radioactive isotope carbon-14. So the amount of carbon-14 in an organism will continue to decrease after the death of the organism. So we know how fast carbon-14 decreases. So we can look at the remnant amount of the parent isotope, or the carbon-14, so this would be carbon-14, as it decreases and accumulates into carbon-12. And we know how long it takes for something called a half-life. And a half-life is the amount of time it takes for it to decrease by half. So this would be, 100%, this would be 50%. Cut that in half again, you get 25%. Cut that in half again, and again. And we're not going to do calculations of half-time. And we're not going to do calculations of half. So the fossil record can provide us evidence of groups of animals, especially how the evolution or change of those organisms happened over time. So mammals have unique characteristics. We have jaws that have a dentary squamosal jaw joint. We have different teeth. So if you look in your mouth, you have different types of teeth, incisors, canines, molars, premolars. And those are changes that had to happen gradually over time. And it didn't just happen in one large jump, but one really cool thing about the fossil record is that it can show us each of those steps in kind of a snapshot view of natural selection over time. So this would be a precursor to a mammal, so not necessarily a mammal yet. And what you can see here is the jaw joint is this orange and green. So this is a quadrate articular jaw joint. Right here, the jaw joint where the lower jaw meets the upper jaw. So 300 million years. Let's jump forward 20 million years, still quadrate articular, green and orange. Another 20 million years, the quadrate, still quadrate articular. And now you can see here at 220 million years ago, the quadrate and the articular are still touching, but now the dentary, which is down here, the dentary, and the squamosal, which is your temporal bone, have started to move together too and created a new hinge. So this organism is kind of a stepping stone where they actually had two different hinges here in the jaw joint. And one of these groups eventually must have found that this was adaptive in their environment and moved forward to what we now have, which is this dentary squamosal jaw joint. These two bones actually moved off to serve a different function. So in you, your articular is the malleus, and the quadrate is the incus. And those are your ear bones, or two of the three ear bones that help you in hearing. So by moving this jaw joint to the squadrary dental, we were able to take these bones that used to be the jaw joint and give them a whole new function. And this might have caused a radiation, this might have been adaptive. In an environment, especially a terrestrial environment, where hearing and better hearing is a good adaptation. So that might be why natural selection kind of selected for this radiation.